Hey, good morning, guys. Happy Thursday. What a beautiful day. Looking out my window, I always like to give you the daily report. It's nice too. Down in my office, I can open up the window, get some fresh air in here. Um, so I hope you get outside and enjoy this day today and enjoy some weather. Okay, so we're moving from this idea of conduction, which you learned the other day was you know, molecule to molecule transfer of energy, or more importantly, contact. And usually in solids. Now today we're going to move to convection. I'm going to try to buzz through some things really quickly with you. Your target's the same. You're constructing an explanation with evidence. We'll probably get to that explanation on Tuesday or Wednesday, where you're going to need to make a claim and support it with evidence. Today's task, you're going to watch this video that you're watching right now. I'll have a short convection video posted. I want you to take a note or two. I'm going to show you that process, or what I would do if I were you, in a minute. Just because then we don't have to worry about paper and everything's electronic, and we can keep it there. And then you're going to create a Flipgrid video with your example of convection. Yesterday was practice. And then my expectation is you'll go away for a while, do what you got to do, other work, or go outside. Come back later in the day and check out the collection of Flipgrid videos. Okay, so let's talk about convection. The first thing I want to do is, and I'm going to show you, this is what I do. I just did this yesterday while I was in the meeting with others. I'll just create a doc real quick if I need to keep track of anything, and I'm just going to call this transfer, need an S in there, of thermal energy notes. And then I'm going to go down here, and since this is just a document I keep, now I know if I type in notes on my Google Drive, this is probably going to pop up. And so we had conduction first, and we said that was the transfer of thermal energy. And remember, this whole unit is all about energy transfer. This is through direct contact. In other words, this is like molecule transferring, oops, too many R's, vibration, maybe too many R's, there's no S, there we go. Vibration from one molecule to another. You can feel free to do the same notes. I'm not providing you a document. You need to learn to do this. Transfer of thermal energy, direct contact, molecule vibration, one molecule to another. And then I'm going to put in here, let me do this. Can I pick a, this is usually happens with solids. So not liquids or gases. All right. What I'm going to do now is go to my next, and I just said we're going to work on something called convection, which is the next energy transfer. So I'm going to put that to transfer of thermal energy, not just energy in this case, but we're talking about thermal energy. And this is a different process, but I'm going to go down a little bit because I'm going to put a highlight of what I know already, and I want you to take notice of what happens. This usually happens with liquids. So I want you to recognize that a way to tell conduction from convection is that conduction usually happens with solids, and convection usually happens with liquids and gases. Okay, so notes. You got to be able to take notes. You should be doing this either on a doc or in some paper. Okay, let's go back to this. I want to show you this guy. Let me get up here. This is 4 hours of watching a lava lamp. I don't recommend it. But I am going to look at this for a minute or two. If you remember at the beginning of the year, earlier in the year, when we talked about my daughter's lava lamp and I brought it in, we were talking about density. And if you recall, there's a lamp at the bottom, and the bulb in the lamp at the bottom heats up. And this was mineral oil, and this is wax, the stuff that's floating around. And so that bulb heats up collections of molecules, right? These globules, I like to call them, of wax. And when those molecules are heated up, or that collection of wax is heated up, remember the molecules move further apart, and that collection of wax becomes less dense. And if things are less dense, they go up, right? So it becomes less dense in the mineral oil, goes up. This lamp is designed a specific way. The shape of a lava lamp isn't just cool, man. It's also designed for a certain reason. One, as these globules get away from the bulb down here, they're transferring thermal energy to the mineral oil as well as the glass and the atmosphere around it. So they're getting rid of thermal energy. The molecules are coming closer together, and they're becoming less, or more dense, rather. The shape of the lamp also helps with that, because as the wax goes up, it's almost forced to be condensed and push those molecules closer together. Would it still drop? Probably, but not as rapidly. So here's a globule of wax that's cooled. It's transferred thermal energy. It's dropped down because it's more dense. Now we have another globule that was heated. It's rising up, less dense, more dense, cooler comes down, less warmer, less dense goes up. And this will continue on as long as you keep that light bulb going. All right? So that, my friends, is a really great first example of convection. It's the transfer of thermal energy through the movement of liquids and gases. So the movement of wax, here we go. We're going to have some cooler, more dense wax come down. There's some warmer, less dense wax going up. They're actually going to collide and then kind of move around each other. So, yeah, I mean, how cool is that? That's convection. What a great example. This happens all over the place. Let's go to this. Anybody, if you've ever made spaghetti or macaroni or anything, if you boil an egg, if you've ever put water in a pot on the stove, which by now at 12 and 13 you should have, this is a really good example of convection as well. You've got the flame heats the water, right? Now this is conduction because it's originally because this hot pan bottom is directly in contact with the water molecules. But once those water molecules are heated and that water becomes warmer and less dense, it rises up towards the top. And at the top, you see all the steam. That's where some thermal energy is transferred to the atmosphere above the pot, and that's why we see steam. But that transferring thermal energy, when warm water comes up, it can't leave an empty space down here, so the cold water comes down. Warm water goes up, cold water comes down. And this movement, this fluid movement, this exchange of thermal energy through collections of water molecules, also a great example of convection. All right. Who remembers this dude, man? If you watch Finding Nemo, and I'm expecting that every one of you by now has, you recall that the turtles ride what something's called the EAC current. That current that these turtles are riding is a convective current. That is the movement of large, biggest current we can imagine other than maybe in the atmosphere. Large collection of water moves because of the transfer of thermal energy, because some of that water's warmer and some of that water's colder. All right. Here's an example. I'm having a hard time opening up these images, but we can look at this one over here. There's a bunch you can Google. So this would be the example of the currents that those turtles ride. The warm water, it's just like the wax in the lava lamp. It's warmer, it's less dense, it goes to the top. As it goes to the top, it's moving in a certain direction, and it's transferring that thermal energy to the atmosphere around it. If you think about where this is, I mean, look at the equator would be like right here, right? So that makes sense. It's transferring thermal energy to the atmosphere around it. And then as it keeps moving up past South America, North America, not sure what happened. Let's go here. It cools. And eventually it gets near the Arctic and Greenland and Iceland and this region up here past North America. And it's cooled so much it's now more dense than the surface water. And it sinks. And it sinks and it sinks as it cools, and then it travels, and then and actually there's a little bit more dynamic that happens down here in the Southern Ocean near Antarctica. This is like a real trading location of water, so a lot of life actually down there as well, because there's a lot of water that mixes from thermal conduction or convection, and then it moves and then it comes back up and it warms. See, solar warming in the Pacific. This would be the Pacific. Hawaii is like or somewhere right out here. It warms. Here's Alaska, California. Again, rich with life. It warms, goes towards the surface, travels then again past Australia and, Asia, Russia, Africa, back up here to where we get towards North America, and then this current keeps going. Okay, another visual of that is this. So this is a video I'll post today as well, and this shows the warm. There's the warm convective current traveling up near, this is South America, North America is right here. Here's Africa. This would be Spain, I think. Europe. And then as it cools, it travels back down that way. You'll see that. They refer to it in the video as a roller coaster. Very cool. I'll have you watch that. Okay, here's a side view of that. Trying to rapidly give you some examples of how this works, how this collection of things move as they're heated and transfer energy. Here's the warm water that's traveling from like the equatorial region. It's transferring heat loss, thermal energy to the atmosphere. This would represent here, this would represent like the equatorial region. As it gets north, it gives up so much heat loss. You can see this would represent kind of Antarctica. The water cools and sinks. There's a region of mixing, also very rich with life. And then that cool water flows back south, and then it's warmed again, and it comes back on the top and flows south. Yeah, I think those are my examples for today. You just got to remember that it's the fluid movement of collections of molecules. And the warmer, the less dense they go up, and the colder, the more dense they go down. And because of that, we end up having convective currents, transfer of thermal energy through the movement of these fluids. This also is how weather's created. And we'll probably talk about that a little bit next week, how we got a nice windy day. Okay. Sorry. Your job is to, after finish watching this video and the 2 other videos I post, I want you to go to the Flipgrid. Well, first think for a few minutes. Think about examples in your house somewhere of convection or outside or whatever. Just think about an example of convection. And then post a Flipgrid video either showing your example, describing your example, one or the other, and then come back later and look at everybody's video. You are all set for today. Once you view this video and the other 2 and take care of your Flipgrid, have a great long weekend. You deserve the break, and I will see you back here on Tuesday. Please email me with any questions, guys. Okay, take care.